This is the third lesson of our last unit, Unit 8, on probability. This note specifically, we will be just expanding on the ideas of theoretical probability that we discussed in the last lesson. So just as a refresher, the equation that we use to calculate probability, or specifically theoretical probability, is the probability of an event equals the number of successful outcomes over the total number of possible outcomes. Okay, so that's as a general rule of thumb there. So to calculate the theoretical probability, all outcomes must be equally likely. So what does this mean? It means that each event has the same chance of occurring because conditions are fair. So again, a person is just as likely to roll a 6 as they are to roll a 4 on a die. Same with flipping a coin. So ways to represent probability outcomes. So tree diagrams are one way of representing possible probability outcomes. Okay, and we saw that in the last lesson, right? So it's asking us to draw a quick tree diagram for tossing a coin twice and list the possible outcomes. So we know on our first toss, we can either get heads or tails. Okay, if we get heads on our first toss, we have two options for our second toss, right? We can either get heads or tails. If we get tails on our first toss, we still, on our second toss, have two options. Our option is heads or tails. Okay, we only have two tosses, so this is the end of the diagram. Remember, when you're listing out the possible outcomes, you're just reading your tree diagram, right? So heads, 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 tails, tails, heads, tails, tails. Okay, so options are heads, 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 tails, tails, heads, or tails, tails. Okay, so those are all the possible situations. So there's only 4, right? So 4 possible outcomes. Okay, and again, that's mostly review, right? You should know how to do that from the last unit. Another way, but this is new, to represent possible outcomes is to use a table. So moving into an example here. Mark, Jenny, and Odo have each won a t-shirt from West 49 at a store grand opening event. Each shirt will be randomly assigned to the 3 winners. One is red, one is black, and one is green. What is the probability that Mark will receive the black shirt? So I'm just going to underline that so we remember that that is our question. That's a very important underline. There we go. So it says use R, B, and G to represent the colors of the t-shirts. In the table, record all the different possible ways the t-shirts can be given to the 3 people. Okay, so obviously R is going to represent red, B is black, and G is green. So your table might look a bit different than mine if you go ahead and do this on your own, but you should have the same outcomes. So because we're looking at Mark getting the black shirt, that's the outcome I'm going to start with. Okay, so it's possible that Mark will get the black shirt, Jenny could get the red shirt, and Odo could get the green shirt. If Mark still gets the black shirt, it's still possible that these two can change, right? Jenny could get the green shirt, and Odo could get the red shirt. Okay, or Mark could get the red shirt, and Jenny could get the black shirt, and Odo could get the green shirt. Mark could still get the red shirt. Jenny would have to get the green, Odo the black. Mark could get the green shirt. Jenny's either going to get the black shirt or the green shirt, or sorry, the red shirt, green, red, black. Okay, so those are all our possible ways that those shirts can be distributed, okay? So in how many different situations can the 3 shirts be distributed? So all we have to do is count here. So we have 1, 2, 3, 4, 5, 6. So there's 6 different possibilities as to how those shirts can be distributed. In how many ways of these arrangements does Mark receive the black shirt? So we're looking just at Mark here, and we can see only in the first 2 will Mark get that shirt. So it's possible that Mark will get the shirt in 2 of these situations. Okay, part C says, what is the probability that Mark will receive the black shirt? So again, probability of getting the black shirt for Mark, the number of times we're successful. So in 2 of those situations, we're successful in the sense that Mark will get the black shirt out of a total of 6. If we divide both of those by 2, we will get 1/3. 1 divided by 3 times 100 means there's a 33% chance that Mark will get that black shirt. Okay, moving on to our next example. Example 2. What is the probability of rolling doubles with a pair of dice? Complete the table below showing all possible outcomes. So again, we're working with a table here, right? We can see that someone has already started our table for us, so we just have to finish it. So you'll notice that on the far left-hand side, this side here, that's the number on the second die, and on the top we have number on the first die. So all we have to do is basically fill in the values. So you can see that this 1, 1 came from these 2. 1, 2 came from this. 1, 3, 1, 4. So this would be 1, 5. And I'm going to just erase that before I write it in. Just wanted you to see where those were coming from. And 1, 6. Okay, so all you're doing is you're using the first number is coming from the top. The second number is coming from the side. And it's a pattern, right? So you should be able to kind of see what's happening. You shouldn't really need to copy this. You should be able to fill this in on your own. So we can see there's a lot of possible outcomes if we're rolling 2 die, right? Opposed to the 1 die we looked at in the last lesson. So this chart is kind of a nice way to organize that information so that it's all very, very clear. Okay, so those are all of our possible options. We're rolling 2 die. So part A says, in how many ways can the 2 die be rolled? So how many possible outcomes? So we have 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5, 6 on the bottom. So instead of just actually counting all those, we can just do 6 times 6 tells us that there's 36 squares that are filled in here, okay? In how many ways can doubles be rolled? So what I'm going to do to count this is I'm going to just circle those doubles. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So that's 1, 2, 3, 4, 5, 6 possible ways that those doubles can be rolled, okay? And as you probably expect, it's asking us, what is the probability of this actually happening? So what is the probability of doubles being rolled in this situation? So the probability of doubles, okay, the amount we're successful, so 6 times, right? There's 6 possible ways we could roll doubles out of a total of 36. If we divide those by 6, we'll get 1, 6. 1 divided by 6 times 100 means there's a 17% chance that we will roll doubles. next example. Complete the table below showing all possible outcomes for the sum of the two dice. Okay, so the sum, when you see sum, you should know that's addition, right? Sum comes from addition. So what we're doing here is we are adding together the number on the first dice, or the first die rather, with the number on the second die. So 1 plus 1 in this column, 1 plus 2, 3 plus 1, 4 plus 1, etc. Okay, 2 plus 1, 3, 4. And you'll notice that they all just go up by 1. 3 plus 1 is 4, 3 plus 2 is 5. 4 plus 2, no, 4 plus 1, 5. 4 plus 2, 6, 3. 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4, 5 plus 5, etc. 6 plus 1 is 7. 6 plus 2 is 8. 9, 10, 11, and 12. Okay, again, recognize the pattern so you don't have to actually take time to fill that in. Okay, so part A says how many possible outcomes are there? So again, we just have to count 1, 2, 3, 4, 5, 6, right? So 6 possible outcomes there, 6 across the top. So again, 6 times 6 equals 36. Okay, and again, if you counted all those squares, you could double check, it would be 36. And how many ways can the sum of the two dice add to 7? So what I'm going to do is I'm going to go through and I'm going to circle every time I see the sum as 7. So there's one, there's one. And again, you'll notice you should get a pattern here. Okay, so those are all the instances that we can get a 7. So there's 1, 2, 3, 4, 5, 6. So there's 6 possible ways that we're going to get 7. What is the probability of rolling 7s with a pair of dice? So again, our probability formula, probability of 7s. Okay, we're successful with adding to 7 6 times out of a total of 36. Again, if we divide those both by 6, that's 1/6. 1 divided by 6 times 100 is 17%. Okay, and lastly, part D, what is the probability of rolling odds? So odd numbers, oops, dropped my pen. Odd numbers are what? 3, 5, 7, 9, 11. Okay. And 1 would also be an odd number, right? But we know that there's no 0 on a die, so we're never going to add up to 1. So again, I'm going to go through and I'm going to circle every time I see a 3, 5, 7, or 9. So 3, 3, 5, 7s are already circled, 9s, and 11. Sorry, and 11. And I'm just going to count those circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Am I missing one? Oh, yes, 18. That's better. Okay, so there's 18 situations where I'm getting an odd number out of a total of 36. If I divide these out, you'll realize that that's 1/2, which means there's a 50% chance of getting a double. Okay, which makes sense. All right, so this is the end of the third lesson that expands on theoretical probability.